Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to control MG995 servo motor with the help of our PCA9685 board. As you can see, this is what PCA9685 servo motor board, and we are going to control MG995 servo motor with the help of our face. So friends, now we are on our desktop Raspberry Pi bookworm. So first, for today's session I have created a new repository. I will mention the link inside description box. You need to simply copy paste the link inside the web browser. So this is what our repository: rpi bookworm webcam face tracking servo. Then go to the code, click on download zip, and it will download our zip format repository. As you can see, we successfully download. Now simply go to the file manager, then downloads, and this is what our repository. Right click on extract here, it will extract our repository as a folder. So right click and then click on cut, go to the home, and then just paste our repository inside home folder. Now simply go inside our repository, and then first let's just see how to connect PCA9685 servo motor board with our Raspberry Pi 4. So I have here inside our repository, I have mentioned RPi4 image, the pins image of our Raspberry Pi 4 board. This is the pins, and then I have mentioned our PCA9685 board image. So this is what our PCA9685 board, and this is what our Raspberry Pi 4 pins. So on PCA9685, here it is the pins: ground, then SCL, then SDA, then VCC and V+, VCC, SDA, SCL, and then ground. These pins we are going to use for controlling PCA9685 with the help of our Raspberry Pi 4. Now as you can see, the V plus pin. So V plus pin, this first pin which we want to connect with Raspberry Pi 4 pin number 2. As you can see, pin number 2, which is 5 volt power. So V plus pin, PCA9685 board, V plus pin connect with Raspberry Pi 4 pin number 2, which is 5 volt power. Then VCC pin of our PCA9685 board, VCC pin connect with Raspberry Pi 4 pin number 1, which is 3 volt. Simple. So first pin V plus connect with Raspberry Pi 4 pin number 2, which is 5 volt, or you can simply connect with pin number 4 because 4 number pin is also power with 5 volt. So V plus connect with 2, or you can connect with 4 number pin. Then VCC pin, as you can see, the VCC, the second pin of PCA9685 VCC connect with Raspberry Pi 4 pin number 1, which is 3 volt power. Then SDA of our PCA9685 board, SDA pin PCA9685 board connect with Raspberry Pi 4 pin number 3, GPIO2 SDA. As you can see, SDA. So SDA of PCA9685 connect with Raspberry Pi 4 SDA, which is GPIO2 pin number 3, a physical pin number 3. Then PCA9685 SCL pin, as you can see, the SCL pin of PCA9685 board, SCL pin connect with Raspberry Pi 4 GPIO3 SCL physical pin number 5. Simple. So V plus connect with pin number 2, or as I mentioned, you can connect with pin number 4 because both pin is charged with 5 volt. Then VCC connect with pin number 1, which is 3 volt. Then SDA connect with SDA physical pin number 3 and GPIO 2, and then SCL connect with SCL, GPIO 3 and physical pin number 5, and then ground pin of PCA9685 connect with the ground, which is pin number 6, or you can simply connect with pin number 14. So ground connect with the ground, which is pin number 6, or you can simply connect with pin number 14. So this is how first you need to connect PCA9685 board with Raspberry Pi 4 board. I hope you all clear. I have mentioned the PCA9685 board image, also Raspberry Pi 4 pins image inside our repository. That's it, done. So this is how I have already connect the servo motor board with Raspberry Pi 4. Now just open repository again and open rpi4.txt simple text file. This is what our rpi4.txt simple text file. So first command, as you can see, the first command, just copy it, copy the first command, open terminal and just paste the command inside our terminal and then just hit enter. It will remove our /usr lib python 3.11 externally managed file. Right now I have already run this command, that's why it say no such a file or directory, because I have run this command already and it's deleted that file. So when you install Bookworm freshly on Raspberry Pi, in that time you need to first run this command, which I have mentioned inside rpi4.txt text file, the first command. So when you run this command, then after we can simply run pip3 command. That's it. So for that, first we need to run the first command and then just hit enter. That's it. Now simply we are ready, and first what we want to do before we run our next command, we need to run sudo raspi, sudo space raspi raspi -config, sudo raspi -config, then just hit enter. It will open this kind of window, simple. Then here we need to select three number option which is interface options. So just press down arrow key button from keyboard, so down arrow, and come to the line number 3 which is interface options, then just hit enter. And then here we need to select I4 option which is I2C enable device. So just again press down arrow key from keyboard and come to the I4 line, again hit enter. And then here of course we need to select yes, so just press tab button and come to the yes, then just hit enter. That's it, we successfully enable our I2C interface. Here simply again hit enter, then press tab button, come to the finish and then just hit enter. We successfully enable I2C devices for our Raspberry Pi 4. Now let's just reboot Raspberry Pi 4 once. I have already done with all this process, so you need to simply first enable I2C devices, then just reboot your Raspberry Pi 4 once. Done. Now we are ready, and then again just open our text file and run second command. Sudo pip3 install adafruit -circuitpython-servokit. This is the package which we need for PCA9685 board. So just copy the command and paste inside our terminal, then just hit enter. It will install adafruit circuitpython-servokit package on our Bookworm 64-bit version. So friends, as you can see, because I have already run this command, that's why it say requirement is already satisfied. So we have done with adafruit circuitpython-servokit package. Now our main package for face detection, also for face tracking, we need CV zone package. So sudo space pip3 space install space CV zone and then just hit enter. It will install CV zone on our latest Raspberry Pi Bookworm. As you can see, it say requirement is already satisfied because I have already installed CV zone. So this is how you need to install all these packages which I have mentioned here. So done. Now simply we are ready and we are going to open our Thony Python IDE. So programming and Thony, just open Thony Python IDE. And here it is, our Thony Python IDE. So go to the file, click on open and go inside our repository. So our repository, RPi bookworm, webcam, face tracking servo, and from this repository simply open test1.py. So test1.py is basically for cross checking servo angle, or we can simply cross check our Adafruit servo kit, import servo kit module which perfectly working or not working. Simple. So this is the test1.py code which basically cross checking for servo motor angle. So if I start the code, then you will see here enter prompt. Here you need to mention the angle. So for servo motor, here I have used MG995 servo motor. You can simply use here SG90 servo motor also, but right now I have connect MG995 servo motor with PCA9685 servo driver board. Simple. So here enter, we need to mention 0 to 180 number, means you can simply mention from 0 to 180 angle. This is the range. From 0, it start from 0 and end at the 180. This is the range for servo motor. So if I mention here 20, you will see your servo angle will change. So if I mention here 10, and then if I hit enter, I can see my servo is basically moving. If I mention here 180, which is the last range, then I can see my servo is completely move at right side. So if I again mention here 100, then my servo motor is a center. So this is the code for only checking if my servo is perfectly working or not with the help of this Adafruit servo kit, import servo kit module. Simple. So just stop it. So now simply we are going to open our main code which basically track our face, and then we can simply control our webcam with the help of servo motor also. So here it is, as you can see, from cvzone.face detection module import face detector. This is what our face detector module. I have mentioned the full code, and then import cv2, and then from Adafruit servo kit import servo kit. This is the two modules, and then on board PCA9685, let me show you here. We have our image. As you can see, friends, on PCA9685 board, we have basically 15 pins. It start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. So if we count like this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 16. So it's basically 16 pins. So here channels is equal to 16. How many pins we have? If we count like this way, 1, 2, 3, so it's become 16. So we need to mention that number over here. So channel of our board is basically 16. Simple. So kit is just a variable, and this variable represent our servo kit module from Adafruit servo kit. Here it is, as you can see, S is capital, so I have mentioned S is capital. So kit is equal to this servo kit, and channels is basically the pins. How many pins we have on our PCA9685 board? So we have 16 pins. That's it. Then cap is equal to cv2.video capture. This is what our basic code. This is what our basic code line for starting our webcam, and here I have mentioned the webcam index number. In my case, I have only USB web camera, so I have mentioned 0. So the web camera which I have connected with Raspberry Pi 4 USB web camera. Simple. Then detector is just again variable, and this detector represent our face detector module from cvzone.face detection module. As simple as. Then when we start our code, in that time the servo motor will move at the 90 angle. 90 angle means a straight angle. So for that I have mentioned by default, when we start our code, servo motor will move at the center, so 90 is the angle, and kit.servo, from this kit we are going to use servo, and I have connect my servo MG995 with pin number 0, this one, pin number 0, the first pin, 0 channel. So for that I have mentioned here 0. Here it is, as you can see, 0. So if you connect the channel number 1, so you need to mention here 1. You need to mention here 1 because you connect your servo motor with first channel. Simple. Then let's just say if you connect your servo motor with channel 3, so here you need to simply mention 3. Right now I have connect my servo motor with channel 0, so I have mentioned 0. And remember one thing, so servo motor pins orange connect with yellow color pin on PCA 9685 board, and the red color of servo connect with red color PCA 9685 board, and the gray color of servo pin connect with black color. Here it is, as you can see, the black color of PCA 9685 pin. So this is how you need to connect servo motor with PCA 9685 board. I have explained all the connection. That's it, done. Now I hope you all clear why I have mentioned here 0. This is basically the channel number. Let's just say if you connect your servo motor with channel 15, so you have to mention here 15. Done. Now while loop, and this is how we call our cap.read, and then we are going to flip our frame, and then we have IMG and B box. This IMG and B box is basically our detector, because this detector is our phase detector. So from detector, as simple as we are going to simply find phases. So this detector dot find F capital phases, it will find the phases, and inside that we need to simply pass our IMG. Done. Now if there is B boxes, means if there is phase, for that we mention if there is B box, because if there is no phase, then of course there is no B box. So if there is a phase, means there is a B box. So simply we can create here condition. If the B box is there, then center 1 is just a variable, friends. So center 1 is equal to, from B box, from this B box we are going to use first point, so first index and then the center. Let me show you here. If I print this center, so this center is basically CX and CY. So if I, let me comment all these things, then I will explain more perfectly. I am going to comment all the code. Now just save it. Now print center, and as you can see, friends, our frame is started, the USB web camera is started, and there is a rectangle on my face, and inside shell, as you can see, there is a 2 points. So first point is basically CX and second point is basically CY. So this is what our center point, so CX and CY. So from this 2 point, if you cross check, the first point index number is basically 0 and the second point index number is basically 1. So for that, if I want to access here this first point, so how can we mention? Simply we need to mention here, if I print center 1, so from this center 1 we have this 2 point and the index number of this 2 point is basically 0 and the 1. 0 and 1. So if I want to access the CX coordinate, so I need to simply mention here 0. Then it will access only the first point, which is the CX. For that, if I now comment this code and if I start a next line code, for that I have mentioned again new variable X medium, and from this center I have mentioned here 0. 0 means it's now only access this first point, CX point of our face center point. Simple. Now from this X medium, now we are going to use here A is equal to, just A is basically simple variable, you can mention any variable. So A is equal to this X medium divided by 62, then we will get, if I print here A, you will get the idea. So now friends, as you can see, it started a frame, it's detecting my face, and there is a rectangle, and inside shell, as you can see, we have value. So right now inside shell we can see there is a 3. So if I go like this way, as you can see the value is basically 7. Now it's increasing. If I go like this side, so value is basically now decreasing. Okay, it's now 2. If I go here, value is increasing. If I go here, value is decreasing. So here inside code, as you can see, the value is basically 5, or greater value is basically 20, and minimum value is basically 1. So for that I have mentioned, if it is in between 5 and 20, the position will be high, means servo motor will be moved at 180 angle, and if the A is in between 1 or 4, servo motor will be moved at the minus point, means it will move like 180, 100, then 20. If A is in between 5 and 20, it will move like this way, 1, 2, 3, 4, 5, 6, 8, 0 to 180. If the A in between 1 or 4, again it will move 180, then 20, then 1, like this way. Okay, when we start our code, you will get a better idea. Now simply what we are going to do, let's just start our code. I have mentioned here print A. Now if I start the code, as you can see, inside shell we have 3. So I forget to start this line because this line is important. So now we have our position. So we need to simply pass this position inside our kit.servo0.angle is equal to position. As you can see, now simply if I save the code, if I run the code, so friends, as you can see, our USB web camera is started, and when we start our code, first time the servo motor angle which we mentioned here 90, so it will move at the 90 angle. Now I need to simply go in front of my USB web camera. As you can see, now it's tracking my face. Now if I move here, as you can see, web camera is also moving with me. It's tracking my face. As you can see, it's tracking my face. If I go right side, here it is. As you can see, it's tracking my face. As you can see, so it's tracking my face because we mentioned here our position. Our face position is basically coordinates for servo motor. So this is how, friends, you can use CV zone phase detector module for controlling the servo motor with the help of USB web camera on latest Raspberry Pi bookworm operating system. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.